Hello students, in the previous lecture topics of equilibrium of coplanar forces and even in the friction chapter of statics, we had come across the pulleys and drums without friction. That means in case of frictionless pulley or in case of frictionless drum, tension in the string or the cord or the wire on the two sides will be same. Now, in this lecture, we are coming across rope or the belt friction. Now, to understand the concept of rope and belt friction, now look at this diagram on the right hand side. Here in this diagram, you can see that there is a rope or a belt which is taken around a friction pulley. It is taken around a friction pulley or friction drum. So whenever the rope or the belt is taken around friction pulley or friction drum, which is fixed in position, and there is friction between the belt and the pulley, tension in the rope on the two sides will be different. On one side, tension will be more. That we called it a tight side. Tension on one side, the tension will be less, which we normally called as slack side. So we'll say the tension, T1 is the tension in the rope on the tight side. T2 is the tension in the rope on the slack side. All right. Mu is the coefficient of friction between the rope and the pulley. All right. Then theta is angle of lap. How do you get angle of lap? When the rope is taken around the pulley, certain part of the rope is in contact with the pulley. How do you get that angle of lap? So from the center of the pulley, we draw perpendicular on the two sides of the belt. Then whatever angle, this part which is in contact with the pulley is called as angle of lap. This part, what angle it subtends at the center of pulley is called as angle of lap, and which is to be taken in radians. So relation between the tension in the belt on the two sides, that is relation between T1 and T2 is E raised to mu theta. T1 upon T2 is E raised to mu theta. T1 is the tension in the rope or the belt on the tight side. T2 is the tension in the rope or the belt on the slack side. T1 is greater than T2. E raised to mu theta. Mu is coefficient of friction between the rope and the pulley. Theta is angle of lap, which is to be taken in radians. Suppose the rope is wrapped around the pulley for one revolution. So angle of lap will be 360 degree or 2 pi radians. Suppose it is wrapped by half ton, then it will be pi radians or 180 degree. Right? You have to take it in radians in the working, in the while solving the problems. All right. Suppose each ton is equal to 2 pi radians. Suppose the rope is wrapped around the pulley for 5 tons. So that means what will be total angle of lap? 2 into 2 pi into 5. That is 10 pi radians. Students, derivation of this expression is given in my book. All right. It is self-explanatory. You can understand it. I'm not covering in the lecture. So you can refer to my book on mechanics. You'll get the derivation of it. Now we are straight moving to the understanding. How do we understand which side is tight side and which side is slack side? For that, there is a note I have kept it here. Note for solving problem. Refer to the figure. Find the minimum force P required to just lift the weight W. Now you can see that this is a friction pulley. Here on one end of the rope, there is a weight W is attached. On the other side, P is the minimum force required to start pulling it up, just to lift up. In that case, friction will be acting in opposite direction, right? So value of P will be greater than W. In this case, when this kind of the wording you come across, when you have to find the minimum value of P required to raise the load, to lift the load, in that case, value of P will be greater than W. Reason for that is P has to overcome not only weight W, but also friction also. So hence, T1 will become P and T2 will become W. Now, other possibility or other wordings, what we come across, find the minimum value P required to hold this weight W, or minimum value P required to prevent the downward motion of this weight. So in that case, as the motion will be of it will be downward, friction will be assisting the your job. In this case, friction will be assisting your job. So in that case, value of P will be less than W, right? Because friction assists your job. Is it understood? So in this case, T1 is W and T2 will be P. So if you remembered it in very simple words, again, I can explain that. Whenever you come across this kind of the value of P required to lift the weight, to raise the load, right? Value of P will be greater than W. Whenever they come across this kind of wording, value of P required to hold the weight W, or value of P required to prevent the downward motion. So in that case, value of P will be less than W. So this way, T1 and T2 can be easily identified. Now, we will take now 5 problems we'll cover in this lecture, which will have part solution will be what we have learned in equilibrium of coplanar forces as well as in friction chapter. Only addition what will be coming in this lecture will be that in all problems, the rope or the belt taken around the pulley will have friction. So the tension in the rope on the two sides will not be same, rather it will be different. Okay, let's take students first problem in this part. In the figure, a mass of 20 kg is held from falling by the force in the rope passing over the fixed rod. What is the value of F? If mu is 0.25, find the value F to just start the mass up. The problem is in two parts. Mu is coefficient of friction, that is given to us 0.25. All right. In the first part, he is asking, we have drawn the diagram on this side. Theta is angle of flap. How do you get angle of flap? From the center of the pulley, drop the perpendicular on the two sides where the rope is wrapped around. All right. So you'll easily understand angle of flap is quarter turn. Angle of flap is 90 degree, or we can say quarter turn. So pi by 2 radius. In the first case, he is asking you to find the value F required to prevent it from falling. This weight. That means value F required to prevent falling it just to hold it. So that means F will be less than 20 kg. F will be lesser than this weight. So F is less than 20 into 9.2, 196.2. So hence T1 will be 196.2 and Newton, and T2 will be F. Now we can use the relation T1 upon T2 is e raised to mu theta. T1 value is substituted 196.2, T2 is F is equal to e raised to mu. Mu is 0.25, theta is pi by 2, it comes 1.481. Now if you use your calculator here, in your calculators, shift of ln function is your e raised to function, we will be using it. So when you press in your calculator shift and then ln, then you'll see that e raised to box will come. In the box, you will type 0.252 pi by 2 and press equal to 1.48. Then you get value F required to just hold this weight or to prevent it from falling is 132.4. In the second part of the problem, he's also asking you to find the value F to just start the mass up. What does it mean? He's asking you to find the value F to start the mass up, means to lift this mass up. He's asking you to find the value required to raise this block. So in that case, F will be greater than this weight. So T1 will become F and T2 will become 196.2. That is the weight of the 20 kg block. Now again, we write the same expression. T1 upon T2 is T e raised to mu theta. T1 this time is F. T2 is 196.2 equal to e raised to mu into theta. That is again 1.481 has to be. Then value F comes up to it 290.6 Newton. All right. Hope it is understood. With the wordings in this problem, you understand how to identify T1 and T2. Angle of flap was quarter turn. That is pi by 2. Now we come to problem number 2. This involves our knowledge of friction, what we have already gained in our friction lectures. In addition to that, we will be applying the relation T1 upon T2 is e raised to mu theta as the rope is taken around friction. I'm reading the sum. Block A weighing 200 Newton is connected to another block of weight W by a cord passing over the rough fixed pulley. The weight W is slowly increased. Find its value for which motion does impend. Take coefficient friction for all connecting surface as 0.2. Now students, look at this given diagram. This is a block of weight 200. Its height is 1.5 meter. Its width is 0.6 meter. It is connected to a string which is taken around a friction pulley at an angle of 60 degrees. On the other side, there is a weight W is attached. He is asking you to find the minimum value of this weight W required to start the motion of this block. Now, first we have to find tension in the string, which is connected to block A, which is required to start the motion of block A. So now there are two possibilities of impending motion of block. Block A is given to you with dimensions. Force causing motion, that is tension the string required to start its motion, it's applied at 60 degrees. So as dimensions of the block are given, there are two possibilities of impending motion. First is that motion may impend in the form of sliding, or it may happen in the form of tipping. Since dimensions are given, so tipping possibility is also to be explored. Now, impending motion of the block A with sliding. When you are talking about sliding, or when you are studying the sliding motion, dimensions of the block are not required. So we draw FBD of block. Weight will be vertically down. Normal reaction vertically up. Impending motion is towards right. Friction is to the left. Tension T is resolved. T cos 60, T sin 60. Now we simply apply sigma Fy is equal to 0. N1 is equal to 200 plus T sin 60. Sigma Fx is equal to 0. T cos 60 is equal to 0.2 N1. Solving these two equations or substituting the value of n1 from here, you get the value of T, which is 122.4 Newton. Now, second possibility of impending motion. Impending motion of block A with tipping. When we talk about tipping, so we will draw the free body diagram at the instant of just tipping. So there will be some changes you'll feel in the find in the diagram. What change will be there? This is the block. Weight will act vertically down at the CG of this block. Tension T is at 60 degrees, so it's to be resolved T cos and T sin. Now, in case when we are considering impending motion with the sliding, normal reaction and friction force are distributed over its base. Now, when you are considering FBD of the block at the instant of just tipping, the block will tip about this corner. When you are applying value T required to just start the motion in the form of tipping, the block will tip about this point O. So normal reaction and friction force will act at this point only, because normal reaction friction force will not be acting over this distributed surface. Is that understood to everybody? So then we have to, and tipping will be possible only when movement equilibrium condition. It is related to movement, right? Tipping means turning, turning means rotation. That is possible with movement. So we straight away applied movement equilibrium condition. So sigma MO is equal to 0. When we apply sigma MO is equal to 0, normal reaction and friction will go off. Even T sin 60 will go off. T cos 60 will give movement. T60 into 1.5 is clockwise. 200 into 0.3 is anti-clockwise. So you get the value of T required as 18. Well, minimum value of T required to start the motion of block A, when we considered sliding motion, was 122.4. When we consider impending motion with the tipping, it came 18 Newton. So hence minimum value of T required to start the motion of block A is 80 Newton, that too with tipping. All right. So first part of the problem is over. Now he is asking value of W required to start the motion of block A. That means if you draw the free body diagram, the pulley, value of W will be greater than T. Value of W will be greater than T. So T1 will be W and T2 will be T. All right. Coefficient friction is already given as 0.2. Now you have to find angle of flap. To find the angle of flap, you need to drop the perpendicular from the center of the pulley. On this side we drop, on this side we drop. All right. Now this is angle of flap is theta. Now you can see that this string is making 60 degree with horizontal. This string or rope is making 60 degree with the horizontal. All right. So normal will make 60 degree with vertical. I hope you understand our geometrical note. This string or line is making 60 with horizontal. Normal will make 60 with vertical. We mark 60 with vertical. Immediately I understand from this diagram, theta is 30 degree, 90 minus 60. Right? That is 30 degree. But we have to take it in radian, 30 into pi by 80, pi by 6 radian. Now apply T1 upon T2 is e raised to mu theta. T1 is what? W. T2 is 80. E raised to mu is 0.2. Theta is pi by 6. Use calculator. It comes 1.111. Then value of W comes out to be 80.8. So minimum value of W required to start the motion of block A is 88.83. So here you have seen that this first part of the problem, value T required to just start the motion of block A. We have already covered this type of concepts in our friction lectures, right? The additional part was this part where we applied T1, T2 relation. Let's move to the next sum. We take third problem. Third problem, determine the minimum weight W to prevent the downward motion of 1000 Newton body. Take mu is equal to 0.2 between the rope and the fixed drum, and mu is equal to 0.3 for other surfaces of part. Now, look at the diagram. Let's look at the given diagram. If you look at this given diagram, he is asking value of W required to prevent the downward motion of 1000 Newton. That means 1000 Newton block is on the verge of going down and W is on the verge of going up. And tension in this part of the string will be T2. In this part, it is going to be T1. Again, I repeat, he is asking you to find the minimum value of W required to prevent the downward motion of 1000 Newton block. That means 1000 tends to go down and W tends to go up. And tension in the string connecting the block W is T2, and tension in the string connecting the 1000 block is T. Now, based on this understanding, first we'll draw the free body diagram of two blocks. First, I start with the FBD of 1000 Newton block. Weight will act vertically down 1000 Newton. Normal reaction will act from this plane N1 and from the other block N2. Impending motion of the block is downward, friction is upward, 0.3 N1 and 0.2. Tension in the string connecting this block is T1. Block plane is making angle alpha with horizontal, normal reaction with alpha with vertical. Based on that, we have resolved the weight. Normal to plane component 1000 cos alpha, along the plane 1000 sin alpha. Here we can write cos and sin. It is given to you 3, 4, so this will be 5. So tan alpha is 3 by 4, cos alpha is 4 by 5, sin alpha is 3 by 5. Now on this block, I'll write sigma Fy is equal to 0. So what is that going to be? N1 is equal to N2 plus 1000 cos alpha. Sigma Fx is equal to 0 will be 1000 sin alpha is equal to 0.3 N1 plus 0.3 N2 plus T. All right. We have written those two equations, but what I find that number of unknowns in this diagram is 3. So I'm stuck. Doesn't matter. We are stuck at this. Now we take FBD of block W. Weight vertically down, normal reaction N2 towards it, impending portion up, friction down, tension the string connecting the block W is T2, and weight is resolved, normal to plane W cos alpha and W sin alpha. Right, sigma Fy is equal to 0 and 2 is W cos alpha, 0.8 W. Sigma Fx is equal to 0, T2 is equal to 0.3 N2 plus W sin alpha. Where substitute the value of N2 and sin alpha, you get T2 as 0.84 W. What you got it? T2 as 0.84 W. We also got N2 as 0.8 W. So now from equation number 1, I'll substitute the value of N2 as 0.8 W, right? And I substitute cos alpha. So value of N1 is arrived at 800 plus 0.8 W. Now from equation number 2, I substitute the value of N2 and I substitute the value of N1. Then I get the value of T1. Now students, so from this diagram, we got the value of T1 in terms of W. From this diagram, I got the value of T2 in terms of W. This is value of T2 in terms of W. This is value of T1 in terms of W. Now we consider the FBD of this friction pulley. Now you can see that these two strings are parallel to the plane. That means you can see that when you drop perpendicular from the center of the pulley on the two ropes, right, you understand that angle of lap is 180 degree or pi radius. Now this tension was T1. There is a mistake in the FBD. Tension on this side is T1 actually. This is T1 and this is T2. All right. Anyway, T1 upon T2 is e raised to mu theta. T1 upon T2 is what it is? E raised to mu theta. This slight printing error. This side has to be T1 and this side has to be T2. Because we understood that T1 is the tension the thing connecting 1000 Newton block and which is lower block. And this is T2. Anyway, T1 upon T2 is e raised to mu theta. Substitute the value of T1. All right. Substitute the value of T2 into the expression and e raised to mu theta. You get the value of W required 175.22. Hope this is all understood to everybody. Let's move to the next sum. Problem number 4. Determine the minimum weight of the block W required to keep the beam in horizontal position of the equilibrium. Assume rough pulley with mu. You are given with a beam where and A is hinged, two reactions. This is triangular loading, or you can say UVDL. There is external movement. Here the beam B is supported, and B of the beam is supported by string, which is taken around a rough pulley. On the other side, there is a weight W attached. He is asking value W required to hold this. To hold this means value of W will be lesser. So this will be T2, and this side tension in the string will be T1. All right. So T1 is the tension the string connecting to the beam at P, and T2 is this weight. Right. That's what we understand. First, we take free body diagram of the beam A, taking tension in the string connecting the beam as T. So this is 60 T cos T sin. 80 Newton meter is external movement. Here hinge means two reactions, HA and VA, directions are assumed. This is UVDL. You have to replace it by equivalent point load. So what is that going to be? Half into 3 into 100. So that is 150. Where does it at? At the centroid of the triangle. So that is 3 by 3, 1 meter from this side, 2 meter from the other side. Now to find the tension, the string will take moment about A. When you take sigma MA is equal to 0, HAVA will go off, even T cos 60 will go off. You get it what? T sin 60 into 5 is clockwise. Even 80 is also clockwise. 150 into 2 is anti-clockwise. This gets the value of T as 50.81. Now we draw FBD of the pulley. When we draw FBD the pulley, this side weight is W, tension. This side tension is T. We already understood that this is going to be T1 and this is going to be T2. All right. Theta. Now this string is making 60° horizontal. Normal will make 60° with vertical. Again, I repeat, this string is making 60 horizontal. Normal make 60 vertical. From this diagram, you understand angle of lap. See, lap starts here, lap ends here. So angle of lap, part of the rope which is in contact with the pulley, makes angle of 90 plus 60 at the center of the pulley. So this is 150 degrees angle of lap. Put it in radians, 150 multiplied by pi 5 by 5 by 6. So T1 upon T2 is e raised to mu theta. Value of T1 is 50.81, T2 is W, E is equal to e raised to mu 0.2 into 5 pi by 6, 1.688. So that comes out to be value of W 30.31. Okay. Okay. We take another problem. Block A shown in the figure weighs 2000 Newton. The cord attached to A passes over a fixed drum and supports a weight equal to 800 Newton. The value of coefficient of friction between A and the horizontal plane is 0.25. Between the rope and the fixed drum is 0.1. Determine the value of P if the motion is impending towards left. Now, let's study this. There is a block A which is resting on the plane, on which force P is applied towards left. He is asking you to find out the value P required for impending motion of block A towards left. If impending motion of block A is towards left, that means 800 will be just lifting up or not, will be going up or not. So students, the tension in the string connecting block A over here will be greater than 800 Newton, because impending motion of the block A is towards left. So tension in the string at this level will be greater than 800 Newton. So 800 will become T2. Tension in this string will be T1 or right. Now, first we have drawn FBD of this pulley. This is 800 Newton, which we called it T2. This tension T is nothing but T1. Tension, this is T1. Now, this string is making 30° horizontal. Normal will make 30 vertical. Lap starts here, lap ends here. So this makes what? Angle of lap is 90 plus 30, that is 120. What is that? Is 120. Right? So theta is 120 into pi by t, 4 pi by 6 radians. Now we understand T1 is T, T2 is 800. T1 upon T2 is e raised to mu theta. T1 is T, T2 is 800 Newton, e raised to mu is 0.1 into 4 pi by 6. That comes out to 1.233. So tension in the string is 986.39. Now we consider FBD of this block A. Weight will act vertically down. That is 2000 Newton. All right. Normal reaction vertically up. P is external force applied to the left. Impending motion of the block to the left. Friction is to the right. Tension T is at 30 degree. Need to resolve T cos and T sin. Need to apply sigma Fy is equal to 0. N1 plus T sin 60 is 2000. You get value of T is already known to us. So you get value of N. Sigma Fx is equal to 0. P is equal to 0.25 N1 plus T cos 60. When substitute the value of T, substitute the value of N1, you get the value P required to just start the motion of block A towards left. So students, this way I have covered 5 problems where I have explained to you how to understand in case of the friction pulley, which side tension is less or which side tension is more. I mean T1 and T2 mainly you need to identify, need to find angle of lap, and then we use the relation T1 upon T2 is e raised to mu theta. Right, students? Derivation of T1 upon T2 is e raised to mu theta is given in my book on mechanics, which is available on Amazon as well as on local bookstores. If you wish to buy it from the Amazon, there is some discount also, free delivery also has been arranged. Amazon link is given in the video description of every lecture. My book has many MCQs are given on every chapter. Many more solved problems, derivations are there. So if you buy the book, it will be definitely advantageous. But even if you're not buying the book, still my lectures will be understood 100% and will be quite useful. I request you all to share the link of my YouTube channel to your friends so that they are also benefited without spending anything. It's my idea of uploading these video lectures is just to give the maximum benefit to the students without spending anything. Buying the book is not going to be a big affair, but it will definitely help you to learn more about this subject. All right. Thank you very much.